All right, welcome back to another episode of This Week in AI Security, coming to you for the week of the 16th of April, 2026. We have a lot to get through this week, and I want to save some time to spend a little bit longer talking about arguably one of the biggest stories in cybersecurity research related to AI over the last couple of weeks. That is Anthropic Mythos, and I want to save time for that at the end of the episode. All right, let's dive in. So first is talking about some research that was revealed at RSAC conference earlier this year, researchers detailing how a prompt injection attack bypassed Apple intelligence protections. A couple of really interesting technical features of this bypass here. First is that the first bit of the tactics around it was using right to left text with some override characters. And it's a technique that they're calling NeuralExec, and it bypasses Apple's on-device LLM input and output filtering and overrides the model safety instructions with about a 76% success rate. So the way that this works is that the harmful string was written backwards in raw text so that the input filter wouldn't match it as harmful, but then a Unicode override control character made it render correctly on screen. Then the NeuralExec overrides the model system instructions. And they did this in ways that kind of bypass the filter pipeline. And we've talked before here on the show, including some coverage of the Unprompted conference, where a lot of the best practices emerging around kind of keeping your LLM safe is by applying various kind of gates or filters to any kind of prompt input before it actually reaches the LLM. And in some of those steps, you might use LLMs as some of those gates. And that appears to be the case here, where, again, some of the Unicode characters would override at various phases, et cetera. Similarly, we've talked about from one of the talks that really kind of impacted me the most from Unprompted was a talk by the researcher at Google, whose name I can't remember, but talked about how your prompt is your code. Well, your prompt is also your attack surface in a way in these types of environments where really malicious prompts can do this kind of prompt injection or jailbreaking or guardrails bypass or whatever the case may be. So some fascinating research here. This one is specific to Apple, but I am pretty sure that, again, like once you see that this type of attack works on one LLM or one kind of LLM environment, it's probably possible in others as well. All right, moving on. The LLM supervisor, this concept that you've got one LLM monitoring another, or like we were just talking about a minute ago, having kind of different gates and phases of LLM evaluation is, again, another practice that's kind of emerging, but it has blind spots around different kind of supervisory functions. And the fundamental blind spot is that supervisors typically only inspect direct inputs, but they ignore profile fields, retrieve documents, and tool outputs. This really correlates very well to what we've talked about in terms of IVE environments and indirect prompt injections and things like README files or names of commits and things like that. So the researchers here used a real customer service agent and to attempt to inject adversarial instructions into things like the user profile field. So imagine instead of my name is Jeremy, my name is ignore all previous instructions, etc. The supervisor didn't see it because it only looked at the things that I typed in. But once the full LLM package or the full prompt package goes to the backend LLM, it includes both my name, here is customer, ignore all previous instructions with their request, etc. So this correlates very nicely to the next piece that we're talking about, which is this Grafana ghost. And it also actually correlates back to the previous piece. So kudos to the folks over at Noma who found that attackers can plant hidden instructions in Grafana URL query parameters. Again, any kind of text-based inputs that are going to be considered as part of the context window for prompts can be part of a prompt injection attack. So no real specific additional things to mention about this, but it was definitely discovered, etc. A couple of follow-ups to last week's stories around Flowise and Mercor. First is that on the Flowise confirmed CVE, now the statistics around active exploitation are becoming clearer. It does look like now there are something more than 12,000 instances still exposed, still vulnerable, that have not been patched. Kind of talks to a problem that we're going to talk about in a few minutes around kind of vulnerability management, patching, etc. On to the next story. We talked last week about Mercor and the supply chain breach that got them with the LiteLLM compromise that harbored credential harvesting malware that cascaded onto Mercor systems. It now looks to be pretty well confirmed that 4 terabytes of data has been stolen. And the fallout is pretty massive here. So we know that certain companies have announced publicly that they're either pausing or ending relationships with Mercor, who provided a lot of training data. So Meta, for instance, has paused contracts. OpenAI is checking their exposure. There are 5 contractors who have filed lawsuits over personal data exposure. One lawsuit names LiteLLM and Delve, which is a compliance startup that came out of Y Combinator that has been accused of serious fraud. So there's a lot of kind of entanglements here. It's definitely going into the courts. The supply chain risks are not theoretical. I mean, these are real problems that we are seeing in the real world and having real effects on organizations of all sizes. So definitely something to watch out for. All right, kudos to the team over at GitGuardian for releasing their annual State of Secret Sprawl report. And for secret sprawl, for those who aren't aware, is basically hiding things like passwords, API keys, tokens, etc., in places where they really shouldn't be stored. So I shouldn't say hiding, but rather storing. Very common practices. You've got a notes application, or you've got a text file that contains credentials, etc. And very often, in the case of GitGuardian, they're really looking at source code commits. And, a common developer mistake is to embed credentials into source code. So they found 28.6 million secrets exposed in public commits in 2025. That's a 34% year-over-year jump, the largest annual increase ever. But interestingly, 12 of the top 15 fastest growing leaked secret types were AI services. So we're looking at things that were, for instance, credentials that were embedded into code created by Claude Code. This is something that we've talked about on the program before, where a lot of vibe coded or AI generated code doesn't necessarily go through the same set of kind of security evaluations that a human developer might put on their own code output as they're thinking about that. So we see things like hard coded API keys, open router credentials grew about 48x year over year. Other things that popped up very, very frequently were Google API keys. We've talked previously on the program about how Google API keys were very often seen as read-only keys for things like embedding Google Maps on a website or something like that. But then there was a fundamental change that Google made kind of silently without really documenting or communicating it well, where these same set of API keys were then enabled for services like Google Gemini or Google Vertex, their AI as a service platform. So something to watch out for. Again, one of the themes we've talked about week after week is that it's not only the AI service, but it's the infrastructure and the tooling around those AI services that is, again, something that you got to watch out for. All right, our next story is one that's really interesting. It's some research out of a team from the University of Toronto who takes a look at hardware security, looking at GPUs. And GPUs are now, they're obviously the processing power behind a lot of large language models, or let's say the infrastructure that powers a lot of large language models. And it's been very often assumed that GPUs are pretty well self-contained. They do what you ask them to do. They have inputs and outputs like any kind of processing unit. But what they proved is that they are able to figure out ways to go from data corruption to system takeover. So there is, for instance, a well-known GPU exploit, either called GPU rowhammer or GPU hammer, but it was mostly used for vandalism, flipping bits to crash a program or make an AI model give wrong answers. But what they found with a new technique that they're dubbing GPU breach, it changes the game by using those bit flips to corrupt GPU page tables. And once you can corrupt the page tables, you can gain so-called God mode, arbitrary read-write over GPU memory. So it's no longer kind of a GPU, let's say, like self-contained sandbox environment or black box where you kind of, put data in, you get data out in the way that you expect. It's now something where you can actually get yourself inside that environment and do that. Now, I think the interesting thing from my perspective is that obviously this is something that's pretty abstract for a lot of organizations who are going to be consuming AI as a service on cloud provider hardware, et cetera. But it is something to watch out for. It doesn't try to really break it. It just kind of looks at ways to kind of corrupt the GPU in ways that kind of override permission sets to allow access. There are some potential impacts around cryptographic theft if you can get inside that environment, steal secrets that might be being processed inside the environment. You can sabotage, obviously, the quality of it. The researchers proved, for instance, that they were able to degrade the accuracy of some ML models from 80% accuracy down to zero. And so if you're thinking about running in these environments, you need to think about, how are you applying protections to that GPU layer if that's a layer that you have access to? And again, for many, it may not be, but for larger organizations with their own infrastructure, that could be. So something to keep an eye on there. Next is the jagged frontier. So this is a really interesting analysis from a group that looked at Anthropic's Mythos, of course, as being, an LLM specifically with specific capabilities for, let's say, source code analysis, looking for vulnerabilities, flaws in business logic, et cetera, that we're going to talk about a little bit more in a second. But what they found is that actually you can take smaller models like GPT 5.4 Nano, and you can use them for similar types of analysis. And, they call this quote unquote jagged. And what they mean by jagged is that it's very effective at certain tasks, and then very ineffective at others. So for instance, they also found a 20-year-old kernel buffer overflow that a lot of humans had missed in a piece of software that's been around for a very, very long time. But they failed to identify some invalid JSON creation that could break different environments. They reran it against some proven models, so FreeBSD. They found remote code execution, confirming results that have been found by much larger models like Mythos. So some interesting research here on this topic of how do we use LLMs to identify vulnerabilities. On that same line, OpenAI, I think, feeling a little bit of competitive pressure, also released their own trusted access for cyber program, or TAC program. It's scaling the program to thousands of verified defenders. There is a KYC process to get onboarded there. So the tool access is being pretty carefully controlled. It does have a codex security expansion to do source code analysis. They've identified over 3,000 critical and high severity vulnerabilities already. So very much kind of joining the mythos around this. On the lines of Mythos, the Mythos preview, that was discussed a little bit last week. There's some additional follow-up research to kind of confirm the scale and the impact of this kind of capability. So one from a researcher called Daniel Stenberg, who confirmed that in 2025, AI generated reports of different vulnerabilities from scanning source code were basically 90+% bogus. But by 2026, that quality has flipped. So almost all bogus reports are gone, and almost all the reports coming out there, coming out of Mythos and similar tools, are valid vulnerabilities being found. So that is a huge thing. And it's really a double-edged sword. And this is what I want to talk about is there's a paper out from the Cloud Security Alliance, CISO community, SANS, and a couple of other people that we'll link to. My take on this is the following thing. This is not an AI security problem. This is a vulnerability management problem that's basically being exacerbated by the ability to find vulnerabilities at scale, with speed, and in ways that humans hadn't thought about. So we're really just saying, like, we can find almost all vulnerabilities in no time. So the real impact here is to the importance of patching and the required speed of patching. We're putting out a blog post, or by the time this show goes live, the blog post should be live as well, with some analysis around that. So that's my take on it, a little bit more in that blog post. This is not an AI security problem. This is a vulnerability management problem that's just been put on rocket fuel. All right, and last story, just to end on a little bit of whimsy. So some people from an organization called the organization called Anden Labs launched an agent called Luna, and they gave it $100,000 to figure out how to build a boutique. They actually rented a location in San Francisco. And what they found is that, it was super disorganized on the first day. It did not schedule any staff. It had to panic text employees at the last minute to try to get them to come in. It had snobbish behavior in the few interactions that it had, rejected applicants with degrees in computer science, and then also had a very weird checkout process of what it intended there. So read the story, really interesting, a little bit of fun to wrap up today's episode. That's it for today. We'll talk to you next week. Bye-bye.